Just as a large overview, we're going to be going over this term called continuous data governance and how that works with something like Spring Cloud Data Flow. I've got two of my colleagues here that are also going to help present. Darshan Kathari from Corelogic, and then I have Corinne Gregorian, who works with me. So let's go ahead and get started with this. So a little bit of a roadmap to start with. I'm from a company called Enfuse, and we'll talk about a little bit about a history of what Enfuse is. After that, we're going to go through what the Corelogic platform is. After that, streaming platforms and Spring Cloud Data Flow, so maybe a little historical view of streaming platforms and why Spring Cloud Data Flow is nice. We're going to talk about pipeline development observations. So as Enfuse developers and pipeline developers, we have a number of years building pipelines for different clients. And in this talk, we kind of wanted to gather up the good, but there's also a lot of cons with the current platforms we see, and then how we kind of solve those problems, or the road to solve those problems, rather. Lastly, we were going to talk about data governance a little bit, and then continuous data and application governance. So that kind of leads me to a question. Out of like the 10 people here, right? Are you all developers, or are there any data governance people in this audience at all right now? All developers, right? Okay. That's good, actually, because we're all developers, too. That said, there is organizations called data governments, right? They exist. They're real people. They have families and kids, and they're probably in your organization, and you might not know about them. And this entire talk is how we kind of bridge the gap between the data governance teams and the pipeline development teams. Moving on from that, a little bit about the company that I run. It's called Enfuse. We offer consulting services to a number of different companies. Right now, one of our main clients is Corelogic, and we actually third-party contract through another great company called ZData, so everybody's a big, happy family. I think we employ some of the best pipeline developers in the world, but of course, I'm extremely biased. Everything we do is in an agile paradigm. We do test-driven development for everything, every application we write. And the main thing that we do is data pipeline development. So think about a current customer that might be in a waterfall method, right, or some kind of traditional development style. And they're doing ETL jobs that have been running since 1970, right? And it's a bunch of COBOL code, and they're syncing to an AS400. Our goal is to come into that client and destroy all of that, right, and bring in modern technologies. Things like Spring Cloud Data Flow provide us really good things like Spring Cloud Stream applications that are Spring Boot based. Stuff gets up and running quick. They're easy to configure, things like that, so that the client can then hire younger people to come in and maintain these pipelines. Not only is it a maintenance thing, but newer technologies are generally better. They're faster, right? Just look at some metrics from Kafka and Confluent, right? The messages can be transferred very, very fast these days. And then, of course, we do general application development as well. But again, our main goal is data pipeline development, which is a series of microservices composed together that we then call like a pipeline, right? That's essentially what it is. That said, I want to give a little bit of time here to Darshan from Corelogic, who's one of our clients that can explain the platform that they've been building up the past few years, and the one that we've been developing on as Enfuse employees. So, Darshan, go ahead.
Yeah, so Corelogic is built on a large data source of real estate, weather data, and other insurance data too. So we have hundreds of data sources, and they're very spread out throughout of all our products. So this gives our customers a substandard experience, and not only that, we also lose potential insights into our data. So Corelogic's solution to this problem was IDAP. IDAP is Integrated Data Analytics Platform. Basically, the goal is to bring all the data that we have from all these different data sources and bring them together to have greater insights to our data, and not only that, to give our customers a better informative experience about about whatever they're doing when it comes to real estate. So we contracted Kalen and Karin through ZData, and they have been instrumental in helping us drive out this platform. And with that, I would like to welcome Karin to talk more about that.
Thank you. Why streaming platforms? Streaming platforms becoming a central place in many software architecture designs. And there is a very simple reason to that. Today, many applications are data intensive rather than compute intensive. So you can't stick anymore to your traditional synchronous request response model, which is rigid, it's tightly coupled, and it's very slow to evolve. It brings you a risk of cascading failures, etc. So to be on the same page with the whole industry and with evolving business requirements, you need a new approach, you need new technologies. And streaming platforms gives you ability to build event-driven applications, IoT, traditional ETLs, data pipelines, which are more flexible. They are open for extensions. They provide you with better latency. Moreover, streaming platforms are not just a messaging tool anymore. You can persist data. You can do real-time processing. There is a lot more capabilities than you think. So streaming platforms today are built with three fundamental ideas: to be reliable, to be scalable, and to be maintainable. And that makes them very appealing to use in production. And moreover, most of the streaming platforms being battle tested at scale in enterprise. Okay, so as you can see, streaming platforms market quite huge. So which one should you pick? Which one should you choose? And before making your decision, you should have think of several factors in the context of your application. Number one, is it how low latency should be? And it will vary depending upon the industry you're working. Say trading platforms where the latency is less than millisecond versus the traditional ETL, well, it takes hours, sometimes days. Number two is how much volume need to be handled. Are we talking about 100,000 requests per second, which can be achieved in a traditional web application via REST API? When you scale, you use non-blocking APIs, etc. Or we're talking about more than 1 million requests per second. Say you're ingesting data from the fleet of web servers, feeding you the logs. Number three, what kind of data analytics and processing you want to do? Is it going to be traditional SQL? Or is it going to be more of a data flow processing, where you ingest the data to the pipeline, and at different stages, you do all sorts of transformations, like filtering, data enriching, etc. Or you're going to do a train and serve machine learning models, which is very popular today, and actually with one of our clients, we have this option. Number four, and the last one, is how good it integrates with other tools. Because we all know that better results achieved when you use tools with combination. So from the past and current experience, Spring Cloud Dataflow worked well for data flow processing. And what is Spring Cloud Dataflow? It's a cloud-native data framework which helps you to orchestrate your data pipelines. So basically, it's a chain of the small Spring Boot applications which are built using Spring Cloud Task, Spring Cloud Stream framework. And as a messaging middleware, you can use something like Apache Kafka, or you can use RabbitMQ, or you can use Google PubSub. Another thing is Spring Cloud Dataflow is giving you a very good tool to create a framework. It gives you a freedom to create custom applications. It gives you out-of-the-box pre-built applications like HTTP source, where you basically can ingest data to the pipeline from some external HTTP service. Or you can use something like AWS S3 Sync, where you feed the data from the pipeline to your S3 storage and save it as the file, for example. But however, I found that most of the time, it doesn't fulfill our requirements, and we have to build our custom applications, custom sinks, processors, and sources. And that's the beauty of the Spring Cloud Dataflow, because it gives you this tool, it gives you framework to build your custom applications in a familiar style, in a Spring Boot style programming model. Another thing about Spring Cloud Dataflow is the messaging middleware, which can be independently scalable, which provides high throughput and low latency. So that's about the Spring Cloud Dataflow. And in most of our projects, we use Apache Kafka as a messaging broker, and we use heavily Confluent Schema Registry and Avro format. But the Spring Cloud Dataflow doesn't bind you to any specific message broker. You can easily migrate from the Kafka to RabbitMQ or to any other message brokers. So here's a couple of observations during our pipeline development. And we'll start with the good. And Spring Cloud Dataflow easily integrates with CI/CD tools like Jenkins or Concourse, which gives your business ability to roll out individual applications of the whole pipeline as they are getting ready for production. Additionally to that, what you can have is ability to upgrade or roll back applications. All you need is just to install Spring Cloud Skipper server. So how that works, for example, you roll out a data pipeline, and something goes wrong. It doesn't work really well, so you want to downgrade it to the previous version, and Spring Cloud Skipper will do the job for you. So another thing, another important advantage is the freedom and flexibility it gives to developer to create those custom applications, because business requirements getting more and more complicated, but it doesn't mean that it should take more effort to develop it. And Spring Cloud Dataflow really helps with that. The dashboard, the UI part, the dashboard is a graphical editor for building new pipelines, and it gives you ability to view all the deployable applications, all the running applications. It gives you all the metrics. Also, there is very simple and easy streaming DSL, where you can define the pipeline, you can launch pipelines. Also, there is a CLI interface available. Spring Cloud Dataflow exposes a REST API where you can compose the data, you can launch a batch jobs, and basically that's how you're going to interact with Spring Cloud Dataflow via the CI/CD. You're going to run the test on your applications, you're going to build your application, you're going to upload it to the remote repository, and then you're going to send a REST request to the Spring Cloud Dataflow, to grab those snapshots, those jars, and compose the data pipeline. Okay, about bad things. So as a developer, it's a very common situation where we have to step in and educate our stakeholders, our clients about the streaming versus batch use cases. What would be appropriate for the pipeline? Because it's not always obvious for non-technical people. Another one, gathering business requirements. It's always been like a pulling a teeth, and most of the time business requirements are not ready by the time the project is started. So it complicates the design decisions, it impacts the timelines, resources allocations, etc. Data auditing and governance have been always a problem. You have the whole data governance team, you have a development team, and there is no good connection between them. There is no tool which allows them to work effectively on a same goal. And that's what the Kalen is going to more talk about.
Cool. Thanks, Grid. So moving on, data governance, the last part, at least the bad part here, let's see if this laser pointer works right here. This kind of leads us into why data governance is needed. So data governance in total is responsible for a number of things that you may not know about as a developer. Number one, who owns the data? Who owns this data before it even hits our source? Who owns the data as it's transformed, right? Who has access to the data when it's transformed? If we're doing something like transformations with Kafka, then we have these individual, Kafka topics, right, that will hold transformed data throughout the lifetime of the pipeline. Well, who gets access to that? How can they use that data, right? Is the data even correct? Is the quality of the data good? And accountability, right? As a pipeline developer, do you want to be the owner of a piece of data that you're writing a pipeline for? And I'll give you a use case real quick, why you don't want to be that person, right? Say, for example, we have, and this is an example of a client of ours, we have, we're streaming through criminal data, right? And the whole goal of this is so that this data can be transformed and curated in a specific way to give to third-party customers who then may use it, say, as a landlord screening. If I'm Joe and I go apply for an apartment, and the landlord runs his background check on me and comes back and says, well, we can't rent this apartment to you because you're a triple murderer, well, clearly I'm not a triple murderer, right? Something went wrong. Something went wrong from the source of the data through those transformations all the way to the endpoint, right? So who is the landlord going to blame for that? He's going to blame the company that provided the data. And then who's that company going to blame for that? It's going to be the pipeline developers because they had complete ownership. They were the ones that wrote the transformations of this data. They should know it's accurate. So what I'm leading into here a little bit is the actual programming model and the tools for the streaming platform are no longer really the big problem, right? Pivotal and Spring have done a great job with Spring Cloud Dataflow, Spring Cloud Stream, Spring Batch, et cetera, to really battle test their frameworks and make sure they're good for enterprise solutions. Now we run into the problem of what about the actual data, right? So we use these tools to move this data, but there's a lot of things about that data that need to be identified and taken care of. Pivotal's Spring Cloud Dataflow is a tool to move it, but so far we haven't had anything that really identifies pieces of data in say, an immutable way, right? So if I'm tasked with writing this criminal pipeline and I don't have any great solution to secure this data or tell people who owns these pieces of data throughout the lifetime of it, I don't know what you would do, but we would probably just add a metadata map to each piece of data going through, right? That metadata would include all sorts of things, what point it's at in the architecture, who owns the data, what transformations have happened to it, et cetera. But that's not very secure, right? That's only secure in so much that nobody has access to wherever that data is being stored, right? So you could think Kafka topics, whoever has access to those, whoever has access to maybe cloud storage where you're persisting this data in between transformations. A relational database, you could put it there, but then you have a DBA team that's now in charge of the security of that data. So none of that is really viable with something like a metadata tag. That's where we come into play. with a product that Enfuse has been piloting the past year almost to make this solution a little bit easier. So these data governance people do exist, and it's very important that pipeline team has a relationship between these. Leading into more of an explanation of this problem, there is a gap. And every client that I've worked for so far, they've had this gap between data governance and pipeline teams. Because you'll get into a situation where you have everybody on board and you schedule your inception, right? Maybe a discovery and framing process before that inception. However, the stakeholders and the client may still be in that old mentality that, well, we just need the data pushed into the AS400. I don't care what you do before that, you just need to push it in there so that, say, our product views still materialize and we can still add value to our customers. So the platform is built, for example, say IDAP, and the stakeholders will set up the schedule and the timelines and everything like that, and then they'll say, okay, pipeline development team, start writing code, right? And as developers, that's what we want to do because that's our job. We want to write code as quickly as possible. However, if we're not provided with those business requirements and that logic immediately up front, it becomes a big issue. You play this hurry up and wait kind of game, right? Where then all of those business requirements gathering effort is now put onto the pipeline team, which they really shouldn't be responsible in the first place. So this gap needs to be solved, this gap between data governance team and pipeline development teams, and that's what we're going to talk about the rest of this slide. So we've been working closely with a well-funded startup that's currently in stealth mode called DATABRIFT. DATABRIFT is in stealth mode, so nothing is public. We don't have a representative of DATABRIFT here with us today. Well, or do we, right? They might be out there sitting, you'll never know, I won't say. But DATABRIFT is a product that aims to solve this problem, aims to fill this gap between data governance teams and pipeline development teams. Each has their own goals, each has their own timelines, but we need to make them work cohesively together. There needs to be a better relationship. So what does DATABRIFT product provide to a company like Enfuse that gets propagated down to our end clients? Number one, they come up with a couple new terms. Number one is this continuous data governance here and continuous application governance. Now, these are terms you probably have not heard today because they invented them, right? They figured if AWS gets to invent all these words, then so do we, right? So we're going to describe exactly what it means for something like continuous data governance, and we're going to describe what it means to have a continuous application governance. In addition to that, DATABRIFT provides us a full enterprise management UI that both pipeline developers get certain views of and data governance gets certain views of, right? So these teams have a unified UI where they can actually see what's going on with the data and give metrics back too. We'll explain more why that's important in a second. And in the Spring-friendly way, DATABRIFT also offers nice developer SDKs and Spring Boot starters, right? And that's the important part for me. Man, I gotta stop doing that. Me as a pipeline developer, I don't want to write a bunch of boilerplate, right? That's why Spring exists. We don't want to write boilerplate. We could want to, prescribe our definitions in our YAML and maybe add some drivers, boot it up, and then we do what we want with it, right? So they're trying to persist with that model. Let's start going, describe what continuous data governance actually is. So to have continuous data governance and application governance, things need to change at the start. In other words, Inception needs to change. Talked about earlier how sometimes the budget doesn't even afford, say, a discovery and framing process before a project begins. You get a 1 or a 2-day Inception, and then people assume that you're off to the races. That's when you get into that bottleneck where pipeline developers then trying to extract business requirements from stakeholders. Inception changes right at the very beginning because DATABRIFT requires you to define smart contracts. So if you don't understand what we're kind of getting at right now is DATABRIFT provides a platform that uses secure distributed ledgers, i.e. blockchain, right? We don't use the word blockchain, or they don't use the word blockchain when they describe these things, because all of these are private ledgers, right? This is data that will never be public. There are no block miners. There's nothing like that, right? There's just certain algorithms that DATABRIFT uses to validate this data as it comes into the ledgers. That said, business logic is converted into smart contracts. If anybody has written a smart contract here, say for something like Ethereum, then you know you're probably going to be writing that in Solidity, right? That's not okay for data governance teams, right? DataDrift goes into this problem assuming that data governance teams do not have the capacity to write code, right? Because why would they be necessarily a data steward? They'd probably be like a developer instead. So DataDrift provides a business-friendly DSL, right? That a data governance person can learn, write the conditions of whatever that data should be. It compiles down to a smart contract, right? Which you might have heard them called transaction processors. You might have heard them called something like magic, right? I think magic is actually a keyword that's reserved for Spring, though, because a lot of that stuff revolves around magic happening in the background. But this DSL should be very easy to write, and it is from our experience, and then it compiles down into these smart contracts. What do these smart contracts provide us as a development team? And a pipeline team. A couple of things. Number one, we can do real-time validation with these smart contracts. So Inception changes saying we need these smart contracts up front. Those are the data requirements that come through. We care about data in, data out. That's tasked then to the pipeline team to make this pipeline happen as fast, as quick as possible. Continuous data governance. So with the secure distributed ledger that DataDrift provides in their platform, we get all sorts of things like data ownership, data access, usage, sharing. All of this is cryptographically secure as any other kind of secure ledger. So you get a lot of things provided. You get a good view of the data at rest. You get a good view of the data in motion. And data is always in compliance. And why? Why is it always in compliance? Well, as your business DSL compiles down to this smart contract, you're going to be syncing it through your pipeline. It's going to hit the ledger, but before it goes into its persistence state or persistence repository, wherever that may be, it has to be validated by the contract that was written by data governance. So any piece of data on that ledger that is in a state that is valid from that smart contract, we know it's in compliance with the rules up front that we decide on in Inception, right? And we have to get moving a little quicker here. Continuous application governance. This is the interesting thing that happened when we started piloting this program. Because of these smart contracts and the Inception process where the DSL and the smart contracts are compiled down onto the ledger, you can have your pipeline team just start immediately. Say, for example, and this is a really basic example, but say the stakeholders need all hotel locations for Marriott within a 5-mile radius, right? In that example, they would use something like Haversine's formula to be able to do a radius around that latitude and longitude and only pick out the pieces of data that they needed. Pipeline team could get off the ground rolling and say, well, let's just give all the hotels in the United States through this pipeline to start off with. They go into the ledger, but only the valid pieces are validated for the data governance team. So what happens there is on the metrics UI, you're going to see two things, valid data, invalid data. At the beginning, you're going to get a lot more invalid data than valid data. That should be an indication to the pipeline team that, hey, maybe we can be a little bit more optimized, right? Maybe we can do some refactoring. How about instead of taking all the United States hotels, we just take that state, right? Deploy again, you see that go down a little bit, right? But maybe we can do something else. Maybe we can implement a formula that makes this a little bit better, right? Goes down a little bit more. So now you have more valid data inside of there than you do have invalid data. So what did we do there incrementally and as a side effect from the data governance team? They dictated to the pipeline development team exactly how to write their transformations. They didn't come down with a hammer and sit next to them and make sure they did everything right, but they did it by this shared platform, right? So it's an incremental process that doesn't slow down development, but its goal is to make sure that those pipelines are scaled and as optimized as possible in order for that data to end up in the ending repository. A little diagram of this would be this, and I'm sorry the UI here is so small, but I had to fit a bunch of stuff on here. So pipeline development team creates these business logic transformations in, say, Spring Cloud Dataflow with a number of different transformations. You have the option to do real-time validation with DataDrift, or you can do a back validation where the data is then checked at the very end to provide a lower latency kind of model. You get the UI from DataDrift, and then you can refactor your applications to meet certain goals. So another interesting thing maybe with these transformations is the data governance team says, I need persistent states, but I have an SLA, right? I need it here and here at this time. That's all taken care of by this, right? Those metrics are exposed to pipeline team. If they're breaking that, they can refactor their pipelines to make them more efficient. Performance is always dictated by the complexity of your smart contracts. If I'm reaching out to third-party APIs or something, of course, it's going to be a little bit slower. That should be kind of go without saying. Real-time validation is possible, and back validation is also possible. So in a criminal pipeline scenario, real-time validation would be very, very valuable, right? In another pipeline that, say, maybe a glorified FTP service, maybe you do a back validation, and you only check it once at the very end, right? So there's different options to increase performance with this. Now, coming from a big data background, I'm always worried about the size of the data, right? I know that with this DATABRIFT platform, as a developer making this pipeline, it's hitting this ledger, and whether it's good or bad, right, it's still going to be on that ledger. So from a big data perspective, I'm moving petabytes of data through these pipelines. What's the storage capacity of something like a DATABRIFT platform in a secure ledger, right? That was one of my first questions. You can do local file system to store these ledgers for integration testing and development, but they already have connectors for cloud storage, so think S3, Google Cloud Storage, that kind of thing. And then, of course, Hadoop, right? If you're traditionally on-prem, you can use something like that. So they've taken care of that. Lastly is the historical audit trail. In the previous example, too, the criminal pipeline, it's very important to be able to pull up each transformation as it went through that pipeline immediately, right? With 20 years of COBOL code, that's not so easy to do. With something like Spring Cloud Dataflow and DataDrift, it's immediate. So if I get a call where litigation might be started from a landlord or something that, I might get a few days to make sure and check that this is correct. I go on to the UI, I can check the ledger all the way down, I can find exactly who owns what piece of data at what point in time, I can find out exactly what transformation in this pipeline affected that data, and then I know I can pinpoint exactly within a matter of minutes where we need to fix that, right? So not only is it good for compliance reasons and legality reasons, but it's also really great just for pipeline developers in general as, sort of another integration testing tool. We can do integration testing on individual microservices and applications, and we can even do it with sample data, but how do we do that with petabytes of data, right? This provides a way to do that. I think our time is up. We're probably over, so thank you guys for staying. But we hope you found this interesting. This is just the first part talk of, you guys were actually the guinea pigs, so this is the first talk of many talks that we'll be giving as we go throughout this relationship with DataDrift, and we hope to show more demos, or a demo in the future at our next talk. And of course, at Enfuse, we're always hiring, so check out our website. I think we're one of the best companies out there and one of the most unique companies that offer specifically developers for pipeline development. So yeah, check us out. Any questions before we end up? I know you guys are probably hungry for lunch right now. No questions? All right, well, thanks for coming. I appreciate it, guys.